Okay, when to use the different kinds of collections. So we have a few main collections. We have arrays, we have lists, we have sets, and we have maps. Lists and sets are actually implement the collection interface. Arrays and maps do not, but they're all considered types of collections. The thing you don't get to see when I'm speaking is these are subclasses of or they're interfaces, but they're children of collection, the collection class, capital C collection. These are all collections, lowercase c, right? Collections with lowercase are things that hold objects, right? Collections with an uppercase are, these kinds of things. There's also underneath this a sorted set and a sorted map. Arrays, they're built into the language. They are a thing that just exist, right? They're accessed through square brackets. They're a contiguous block of memory. You can access them quite quickly. That's about all there is to that. Lists, there's two main kinds. There's array list and linked list. There's a few others, but these are the most common. An array list internally is implemented as an array that just grows as needed. If you're using an array and it needs to grow, you have to manage that. If you're using an array list, it does it for you. Um, again, if you know how big the array is, use an array. If you don't know how big it's going to be, use a list. Odds are you're going to want to use an array list. If you don't use an array list, use a linked list. That's fine. It's just remember a series of different nodes. The big difference is this is one chunk of memory. This is individual chunks of memory all over the place. This could be slower because of the way the computer hardware works. If you want to know more about that, take a computer architecture course. Sets, there's two main kinds of, well, there's hash set, which is a set, and tree set, which is a sorted set. The difference between the two, as you saw in the previous videos on the set, no, you didn't quite see it, but imagine that we took those numbers and gave them in a different order. We will wind up with a different tree. Well, we did see that because we saw the one where it was we added them sequentially, and we wound up with just a great big linked list. So if you change the order that you add things in, you're going to wind up with a different tree potentially. It depends on how they've implemented the set. So you don't get a consistent thing, but it's fast. However, sometimes when you're iterating over a set, you want to get the like alphabetical A, B, C, D, E. In that case, use a tree set. It's a different way that they store things in it, and it's more expensive. And your key, the thing you're putting in has to implement the comparable interface. We'll see that with the code as well when we type up some code. Maps. Sorry, this should be a hash set. Maps, very similar, have a hash map and a tree map. Hash map, same idea, quicker to access. The keys are in a seemingly random order, whereas a tree map, the keys are sorted alphabetically. The alphabetical sorting, again, the key has to implement comparable, and it's going to be slower. I don't know how much slower. I don't really care how much slower. The general rule of thumb, quite simply, is use an array when you know how big the data is. Use a list when you don't know how big the data is. You might want to read it in as a list and then convert it to an array if you're gonna if you have code that just reads it all in, and once it's read in, it never changes, and you're just gonna process it a whole bunch of times. It's probably faster to have it in as an array. So it wouldn't be a bad idea to do that. So know how big it is, don't know how big it is. If you want to maintain the order or a particular order, lists make good sense. Sets, when you need to know if something's in there quickly, um, and you want to be able to add quickly and all that, and you don't want duplicates. And maps, when you want to be able to look something up. Sorted set, sorted map, only in cases where when you're trying to display it in some way, iterate over it. So you've got something and you want to add it into the database and you want to make sure that it gets added to the database alphabetically. Why? I don't know, but maybe you do. Then you'd use a sorted set. So it's only in cases where you truly need it to be sorted. If you don't need it sorted and you just want to be picky, it's not a good reason. Okay, so use the sorted set and the sorted map only when you need things to be, um, when you iterate over them, to be in a consistent order. It doesn't have to be alphabetical. You could make it reverse alphabetical. You could make it so that you know people's names that you like go at the top of the list, and people's names you don't like go at the bottom of the list. If you can write a comparator for it, you can do that. Um, So arrays, you know how big it is. Lists, you don't know how big it is. Sets, you want to ensure there's no duplicates. And maps, you want to be able to look something up quickly and look up a key, get a value. Look up a word, get a meaning. Um, those are the basic reasons why you would do the particular different collections. So let's take a look. I don't need to code this part. Let's just take a guess at a few different kinds of scenarios and see what makes sense. So since we're in school, we can use um, we can use school related stuff. So let's say I'm the instructor and I've got a class list. What collection would you use for the class list? You can pause the video and think about it. I'll give you my answer. So if you've got a class list, basically it's just a thing of maybe the student number, first name, last name. Right? That's what I get for an attendance register kind of thing. Notice that that is fixed in size. It doesn't change once I've got it. Once the class starts, typically. It'd be rare that it would change. So I could use an array for that. That's one option. I could use a list for that because um, it's a list. I wouldn't use either of those actually, though. I would probably just use a sorted set. Wait, didn't I just say, you sorted set sparingly? Yes and no. So I do a sorted set either on student number or more likely the last name. Uh, Last name, then the first name, right? Then the student number, or student number, last name, first name. But more likely it's going to be last name. Um, I can have two students with the same last name. So just doing a set on string isn't going to work because if that's just your last name, you can have two students with the same last name. So I'm much more likely to do a set of students, where a student has fields in the instance variables for their student number, their first name, their last name, and then I'm going to write some code. And again, we'll see some code for or you yeah there is code for the comparison stuff. So that would be a class list. What about a waiting list? Say that we only accept 20 students, and if you try and register after that, you go into a waiting list. So what would you use for that? Pause. Okay. So a waiting list, it's the same information, the student number, last name, first name. In this case, I would use a list. Um, I could use an array. List makes more sense because I don't know how many students are going to get added to the wait list. And I do need to know the order that they appeared because, the first person on the wait list, if somebody, decides to drop the course, they're the first person to go in. So I would use a list because that order is important. Okay. And last one, what would you use to store grades? right? A student's GPA, for example, or the courses that a student's taking, that kind of thing. Okay, so in that case, what I want to do is to be able to look up, given a student number, I want to be able to look it up and get their GPA or get their list of courses. So since I want to use something to get something else, it's going to be a map, right? It's a lookup, it's a database call, it's a query, right? All those kinds of words, when you're thinking about it that way, indicate to me that I would use a map. Um, in fact, I would, for all of this, I would use use a database in reality, and a database is essentially a really fancy way of implementing a map or a dictionary. Um, don't tell database instructors that; they'll probably get mad at me for saying that. But in reality, the lowest level, it's basically that. Um, but so when you want to do any sort of query against a database, it's sort of what is it going to return, right? So if it's going to return a single item, then quite often it's just going to be a map. If you want a collection of items, it's going to be an array or a list or a set, depending on the kind of things you want. So that covers the collections. So we've seen arrays, we've seen lists, we've seen sets, we've seen maps. We have a rough idea of when to use them, and I think that will sum it up.